This video addresses the backside of the Similarity Postulates notes for these 9 practice problems and goes through kind of the mindset behind finding your answer and checking your correct answers. So the directions say determine if each pair of triangles below is similar, and if so, be sure to include which postulate proves it and then complete the similarity statement. And then I'll just go ahead and say if they're not similar, you can just put not similar. Okay, for number 1, first of all, I want to look at what information I'm given. I notice that I do not have any information about the angles, and I have 3 side lengths. So my only shot at this is SSS, okay, if they are indeed similar. So what I have to do, though, is I have to show that my 3 sides are proportional to each other. So I'm going to set up an extended proportion. And there are multiple ways to do that, but I'm going to go ahead and say, okay, 48 of this triangle is corresponding to 8 of this triangle. And I want to know, does that equal, let's do 72, which corresponds to 12? And does that equal the third, side 84 over 14? And again, you can do cross multiplication, but if you cross multiply, you have to make sure that you cross multiply and check this proportion, and then go ahead and check this proportion. So the easier thing to do here might be to just divide this in your calculator. 48 divided by 8, 72 divided by 12, 84 divided by 14. And if you do that, you're going to get that all of these are equal to 6. Which means that the 3 side lengths are proportional to each other. So then we can go ahead and conclude triangle CBA is similar to triangle. Now C, here, these triangles are kind of reflected over each other. So C is going to correspond to angle F. B, this angle here, must correspond to angle G, and then A up at the top corresponds to H. And they are similar by the SSS postulate. So this is your final answer. Okay, number 2, I have no information about the sides, but I have some information about the angles. We see here that angle T, it's already marked, has 1 arc mark, so it is congruent to angle J. And then I have that angle U has 2 arc marks, and it is congruent to angle K, which has 2 arc marks. So this one's really easy. We're going to use AA to show that triangle JKL is similar to triangle. So J has 1 arc mark, so it corresponds to T. K has 2 arc marks, so it corresponds to U. U. And then lastly, we're going to have V. So triangle TUV by the AA postulate. Number 3, the information that I'm given, I see 2 pairs of sides. And we also know anytime you see a configuration like this, go ahead and put, you know that those angles in the middle are congruent to each other because they are vertical. But you can't just go ahead and assume, okay, I've got SAS, because you always have to double check and make sure that your sides are indeed proportional. So let's set up a proportion. Let's go ahead and compare 16, so this side, to, now here's kind of the tricky part. 16 actually corresponds to 40. Because these triangles weren't just flipped over each other, they were kind of rotated. So 16 over 40, and I want to know, does that equal? The other length of the small triangle is 16, and that corresponds to 39. So hopefully you know off the bat, whether you cross multiply or you divide, 16 over 40 is definitely not equal to 16 over 39, which means that they are not similar. Number 4, I have a 61-degree angle is congruent to 61 degrees. So that's 1 pair of angles that are congruent. And I have, again, you see kind of this double triangle configuration where they meet at a point in the middle like this. And then we also know that this angle H on the left side is congruent to that on the other side, because those are vertical angles. And my favorite similarity postulate, because it is so easy, is AA. If you just have two pairs of congruent angles, you are done. You're good to go. So triangle HGF is similar to triangle. H corresponds to itself, so it's going to be H. Then G is the 61-degree angle, so it has to correspond to T and S. So triangle HTS. Number 5. Again, I have two pairs of congruent sides, and I also know by vertical angles that this angle in the middle is congruent to, or they're congruent to each other. So I'm thinking SAS, right, because I have two sides and the angle in the middle, but I have to prove it. So let's go ahead and set up a proportion for the side lengths and make sure that it works. So I'm going to set up little triangle to big triangle. So I'm just going to pick any measurement. Let me pick 8. Now, 8, if you struggle with what 8 corresponds to, then just look only at this triangle and say, okay, 8 is the smaller measurement. 8 is less than 14. So 8 must correspond to the smaller measurement of this triangle, which is 28. Okay, both of those are the small ones. So 8 over 28. And I want to know, does that ratio equal the other pair of sides? 14 is the bigger length, so it must correspond to 49, which is the bigger length. And again, you could cross multiply this if you want, or you could just go ahead and simplify those fractions. And if you simplify them in your calculator, you'll get a decimal, but then if you hit math, enter, and you convert that back into a fraction, or if you just reduce these by using what you remember about fractions, they both reduce to 2/7. So that means triangle VUT is similar to triangle. So V obviously is corresponding to itself. U is this obtuse angle here. So it has to correspond to the obtuse angle in the other triangle, which is L. And then the last angle is M. And then we said earlier we have two sides and the angle between them. So therefore they are similar by the SAS. Similarity postulate. For number 6, I have lots of information here. This one looks a little bit confusing. So the first thing that I would do if I were you is kind of highlight or bold or whatever the little triangle here to realize that we're comparing this small triangle to the large triangle FDE. So we're comparing the pink one to the red one. Okay, so I know nothing about angles, right? Except I also know that this angle here in the middle is, angle F is congruent to itself. It's shared by, you can't see that red color very well. Let me change it to something different. I'll change it to this bright blue, this blue triangle. So that angle F in the blue triangle is congruent and shared by angle F in the pink triangle. So I've got all kinds of side lengths. So let me go ahead and check the 3 side lengths and see if they are indeed proportional to each other. So I'm going to start with the small triangle. I like to do little triangle over big triangle. So in the small triangle, I'm just going to do the bottom side, which is 44. And so 44 is going to correspond to 121. So I want to know, does that ratio equal? Now pick another one. Let me pick this side here. The problem is I don't know what it is, do I? So in order to find that, you're going to have to do some math, because it's math class. So if this big side's 143 and this little side's 91, then in order to get this length here, I'm going to have to do 143 minus 91, which is 52. So this length here is 52. That corresponds to, so that's the top part of the little triangle, and it has to correspond to the top part of the entire pink triangle, which has to be this big measurement, right? These two correspond to each other. So 52 over 143. And is that ratio the same as the third side of the small triangle is this one here? But again, I don't know what that is, so I need to subtract. If I do 88, right, because that's this big length here, minus 56, then I end up with 32. So that's the third side of the little triangle. And 32 corresponds with the left side of the big pink triangle, which is 88. So the trick here is to never ever use, you will never use this length here of 91 and this length here 56 in your ratios, because those are not complete parts of the triangle or complete sides. Those are only like parts. So then if I reduce all of these in my calculator, all of these three fractions end up reducing to 4 over 11. So they are proportional to each other. So then we can go ahead and conclude triangle FED is similar to triangle. Now F corresponds with itself. And angle E in the big triangle, this angle here, will correspond to angle R. So FRS. And then we've proved that the three sides are congruent, or the three sides are proportional, so we could use SSS. But in actuality, because I mentioned this angle here earlier, angle F, you could also use SAS because you have these two sides and the angle in between. So I would actually take either one of those answers. For number 7, I've got two pairs of sides. And I have the angle. Notice that angle is between the sides. That's important, right? This one has two marks on it. This one has two marks on it. It's between the two sides. So now I need to check, are those two sides proportional to each other? So I'm going to set up 9 over. Now 9 is the smaller of the two numbers in this triangle. So I know it has to correspond to 27. Because it is the smaller of the two numbers. So 9 over 27, I want to know, does that ratio equal? The other length is 10. 10 is the bigger number of that triangle. So it must correspond to the bigger number of this triangle, which is 30. And if you cross multiplied or you reduce those, you would end up with 1/3 for both of them. So it checks out. So then we can say that triangle VTU is similar to triangle. So V, this one can get kind of tricky. V, notice, is across from the biggest side. So it has to correspond in the other triangle to E across from the biggest side, which is 10. So E. And then T is the one that's the green. It has the two marks. So that one's easier. It corresponds with C. And then the last angle is D. And then we've proved that those are similar by SAS. Okay, number 8. We have lots of angle marks here, but the thing to note is that none of these angles are congruent to each other. Notice the different number of arc marks. This one has 1, angle C has 1, angle F has 2, and angle G has 3. So that's basically just saying all of them are different from each other. Okay, now we could go ahead and conclude we know that this angle in the middle, angle E on both sides, is congruent to each other, or vertical angles are congruent. But since there are already 1, 2, and 3 arcs being used, I actually have to use 4 because I don't know if that's congruent to anything else. So we know that the vertical angles are congruent. Vertical. But we know nothing else. We don't know if any of those other angles are congruent because they have different numbers of arc marks, and we know nothing about angle B. So as tempting as this one might be, because you have all kinds of angle information, you have to have two pairs that have the exact number of marks. So this pair has 4 arc marks, but there's no other pair that has the same number of arcs. Lastly, number 9, we've got 2 triangles, and we've got nothing about angles. We have everything about sides, so we need to check the proportions. So again, let me go ahead and set up little triangle to big triangle proportions. Now, this is not the only way to do it, but that's just kind of a way that is foolproof, if you will, sometimes. So let me pick 15. It's the smallest number. So 15 being the smallest number of this triangle must correspond to the smallest number of the other triangle, the big one, which is 42. And I want to know, does that ratio equal? Let me pick a different number. Let's pick the biggest one. Let's pick 30. So 30 must correspond to the biggest number. It looks like a hypotenuse, but we don't know if it's a right triangle, of 84. And does that ratio equal the same as the third one? So it's going to be 25 over 70. And if you were to divide those three fractions in your calculator, they would all reduce to 10 over 27. And again, I'm getting these fractions, guys, in your calculator. You're going to get decimals, and you can compare the decimals if you'd like. But in your calculator, as soon as you get that decimal, if you hit math, enter, it'll convert it back to a fraction for you. So that's going to be 10 over 27. So they all reduce to that same fraction. Therefore, we can conclude triangle UVT is similar to triangle. So let's see, U is across from the smallest side. So the smallest side in this one is going to be 15, so that's going to correspond to R. And then V is across from the middle side, so it must correspond to across from 25 is S. And then Q. And then again, we only know the three sides, so it has to be by SSS.